on that quiz, we made each question worth 4 points. And if you showed your work, you get 2 points just for showing your work. So if you got it wrong and you didn't show any work, it was -4 on each question. All right. The other thing on that quiz is the cube one on the back page. What is the length it gave you? 8 or 6?
For what?
I think it was 8. What's it? Oh, yeah. Suppose that's not a bad idea. All right. So on that cube problem, it asked for the surface area. And a lot of us just took 8 times 8. Said 64, and that was the answer we gave us. But what do we have to do? What was the last step?
You have to times it by how many faces there are.
And how many sides are there on this guy?
6.
6. So once you did this, you had to take 64 times 6 for the number of sides there. And I think 384 was the right answer. Is what you should have got. So a lot of us just put 64 as our answer on that one. Just make sure you're doing that last step and taking it all the way. All right?
I was too lazy to do that. I think it was you.
Is that what we're going with?
Yeah.
All right. Let's get into the lesson then. 5-7. I'm going to start talking about some expressions and equations with variables. So our first problem here says Cecilia is 4 years older than her brother Brandon. Write an algebraic statement that describes Cecilia's age. So it says X is going to be Cecilia's age and Y is going to be Brandon's age. What kind of statement would we write there? Anybody have an idea?
Well, Cecilia is 4 times older.
No.
Then you just say it'd be Y times 4.
It wouldn't be times though, because she's just 4 years older.
Plus 4.
That's gonna be. It's not gonna be greater than. So we're looking for. It'll be +4.
Yeah.
But we're looking for Cecilia's age, so we know that's gonna be on the other side of our equal sign.
X is greater than Y.
Not greater. Well, that is true. X is gonna be greater than Y. But we're looking to figure out Cecilia's age, so we're trying to solve for X.
Plus Y.
It would be Y plus 4. Because we know Cecilia is 4 years older than Brandon. So X equals Y plus 4. Because whatever age you plug in for Brandon's age, so whatever you plug in for Y there, Cecilia will be 4 years older than that, so we add 4.
So Brandon's 2 and Cecilia is 6.
That could be one example, sure. Any number you plug in here, Cecilia is always going to be 4 years older. So X equals Y plus 4 there. Next one, it says there are 5 times as many students as adults on a field trip. Write a statement that describes the number of adults on the field trip. So this time we're looking for number of adults. So what's going to be on the other side of the equal sign?
Y.
X will be isolated, right? Because that's what we're looking for. That'll be the isolated one. Now how are we going to figure out how many adults there are?
Y times 5.
Not times. That'd be if we're looking for Y. It would be X times 5. Divided, right? That's the opposite. Y divided by 5. All right. So now the next question says if there are 9 adults on the field trip, how many students are there? So what does 9 go in for? Which variable?
The adults.
Well, which variable is that?
X.
X. Now we have 9 equals Y divided by 5. So how do we solve that?
45.
Okay, how'd you get that?
9 times 5.
We multiply each side by 5. And we get Y equals 45 is our answer there. Students would be our label. Everybody okay with that?
Yeah.
All right, so 3 is multiple choice. It says there are 10 less cats than dogs at the kennel. If D represents the number of dogs and C represents the number of cats, which algebraic statement represents this? So which statement would show that there's 10 less cats than dogs at the kennel?
D.
Not D.
Or not D, I mean B.
B?
Yeah.
Why B?
Because if D minus 10 equals C, and the D shows the cats, and then the C shows the cats, and then the D is the dogs.
Yep, so if there's 10 less cats, Then dogs, we need to take our dogs minus 10 to get our cats. So everybody okay with B there for 3? All right, 4, we're going to solve a few now. So we solve each equation for K, and then show your work when you do it. All right?
You got me.
So why don't you guys take some time and work those out, and we'll talk about them once you're done.
It's impossible.
They are not impossible.
Asia, be quiet. You should watch Star Wars. That was really good. Huh? Does anyone have $250? My friend's selling his Lego Death Star. They say he's selling it for cheap.
All right, do we all have something for each one?
No. Yes.
How many you got left, Lana?
I'm on the second last one.
All right.
What is 2K? Is that like NBA?
It's like what's the number that goes to K?
All right, we'll talk about it. Let's start with number 4. 100 divided by K equals 10. How do we figure out this one?
10 times 10.
All right, so you can say 10 times 10 gets 100. Our answer is 10 there. We could take 100 divided by 10 would be another way to solve that one
That's
too.
what I did.
Yep,
Hey, show your work, Mr. Scott.
we're getting there. Don't rush me. So you could take 100 divided by 10 would be another way. Or you can just look at this and say, what do I need to multiply 10 by to get to 100? And you could get 10 that way. 5, what's K there?
4.
4, how do we find that out?
I don't know.
Aside from
18 minus 22 minus 18.
22 minus 18.
I used my fingers.
You could just count it out, right? You could just say, what do I need to add 18 to get 22? But if you take 22 minus 18, that'll give you your answer. So if the numbers get a little bit bigger and it's not as easy to just count on your fingers, you can subtract like that. 6, 10 times what equals 60? So what's K?
6.
6. And how would we find that out?
60 divided by 10.
Take 60 divided by 10. Next one, what minus 50 equals 25? 75. How'd you get that, Asia? We could add there to figure out, right? Since we're minusing 50, we'll have to add 25 to it. So we take 50 plus 25, that'll give us 75. Next one, what times 3 equals 15? How would we figure this one out, Caleb? It's 5. And how'd you figure that out? You just knew it. We could take 15 divided by 3, right? Again, if the numbers get a little more complicated and we can't just do it in our head, we divide there to solve for that one. Now 2K, not the video game.
It's
0.
It's not 0.
It's 20.
It's not 20.
It's NBA 2K.
Asia?
I put 0.
Me too.
All right. So when we have a number next to a variable like this, that means we multiply.
Well, no one told me that.
Well, now I'm telling you.
You tell us this
All right.
now.
So what times 2 plus 10 equals 30? Not 5. All right, so let's step by step. So first we know we have to add 10. So what do we do with this 10 on both sides? If we're adding, what's the opposite of adding? So we're going to take 30 minus 10. So minus 10 here, minus 10 here. And that equals 20. So now we have 2 times k equals 20. And now that we're multiplying, what do we do? How do we solve this one? If this is 2 times k. We don't know yet. That's what we're trying to figure out. So how would we figure out what k equals?
The number's 30, so I got 10, so
10 is right, because we take 2 times 10 plus 10 to get 30.
What the heck?
So we would divide both these by 2 here. Right? So if we divide them both by 2, we get k. And then what's 20 divided by 2? Be 10. You see the steps we followed to figure out k there?
I just guessed.
I could just took 20 minus 10 or 30.
Alright, so we had 30 as our answer. We had 2 times k plus 10 equals 30. So first we subtracted 10 from each side. So then we had 2 times k equals 20. And just like up here, we divided, right? When we had 10 times k equals 60, we just divided. So once we subtract 10, we have this same kind of problem where we can just divide to figure out what k is. So remember that when you have a number next to a variable like that, that just means we multiply. If there's no sign and they're stuck right next to each other, we multiply. All right. Next page of notes, lesson 6, algebraic expression.
Wait, so what's the answer?
The answer would be 10 on that one.
That was close.
If you take 2 times 10,
You get the zero. You good?
Yeah, I had an 8.
all right. Landon, you want to read that first bullet?
The algebraic expression are made up of parts called blank. An expression, is that duos or
Does.
does not contain an equal sign.
All right.
EX.
So what we're looking for
So is it Pokemon now?
is terms, is what goes in the blank. Algebraic expressions are made up of parts called terms. And like I said, they do not have an equal sign. So some examples, you could just say 3 plus 7 would be an expression, right? No equal sign. Or if we use variables like we're going to start, you could just say x plus 5 are some examples of expressions. The 2 types of terms, we have variable terms, which are terms written as a, anybody know? What's a variable? It's a letter. It's a letter. And they represent unknown values, right? What we don't know.
Huh?
That's what variables represent.
No, I can't spell.
Unknown values is what that says there.
I can't.
I'm not being
Mhm.
Because I can't see the scribble to it.
Unknown values.
And I'm writing it in the wrong spot.
Oops. All right. So examples, we've seen X, we've seen Y. It can be any letter though. I know what's your favorite letter?
Z. L.
Z, K, L, all could be variables.
Can't want y'all.
All right, so any letter. Any letter can be a variable. Doesn't matter.
What about the alphabet?
Any number in or any letter in the alphabet would be any letter.
So a letter K could
How do you spell
K could have been. What?
How do you spell
AY. I don't know. All right, number terms.
Is that like the alphabet saying the letters? I thought you had to spell them out. Like B, I thought it was B-E. And like T, I thought it was T-E.
Why would it not be B-E-E?
I don't know. And then Z, I thought it would be Z-E.
All right, let's get back on track. Number terms are terms written as a number. That one should be pretty easy.
Where does number land?
Number. Number terms are terms that are written as a number
Yeah, that's the password.
that represent
Oh, I had a number 2, 3.
its value. So examples. Any number. Any number in the alphabet, right, Landon?
Yep.
1, 10, 100,
That's
negative 5. We're talking about numbers. So it can be any number.
Negative 1,000.
Sure. So going back to our terms, number term or variable term?
Number two.
Number term, it's just a number, right?
Yeah.
Number term,
Variable.
just the 5 though.
Number.
And the X would be the variable. Alright?
We should get extra credit if we say a funny joke.
Alright.
Then you lose points if it's not funny?
Yeah. How's that work?
No.
You already said something funny that made everybody laugh.
Alright.
Yeah, we should get extra credit for your joke.
I'll give you a high five after this. How does that sound?
I did Asian that one time.
Alright. So now we're going to use our tiles again with variables this time. So the same thing, we're going to have open square is positive 1. Filled in square is negative 1. When we have X, we're going to use rectangles to represent an X term. And a negative X is going to be a shaded rectangle. Alright, so if we just have X plus 4, how many rectangles am I going to have? Landon, how many rectangles am I going to have?
4.
Nope.
Well, the X though. Oh,
Okay.
you'd have 2.
Nope.
No, 1.
1. We have 1X, so we just have one rectangle. Is it open or closed?
Open.
Open. And now how many squares am I going to have?
4.
Not negative, it's positive 4, right? So that's how we represent that one. Now this next one, Landon, how many rectangles am I going to have?
1.
1. Same, just 1X there. And now, how many squares am I going to have? Not positive, we're subtracting, right? So we're going to have 3 shaded in squares
Wait, where's negative?
because we're minus 3. X minus 3.
We put the minus against the 3, so it's negative.
So that's what we should have for those two. All right, coefficients are the number in front of the variable that represent how many of that variable we have. So here, how many x's do we have? 2 x's. And this 2 right here would be our coefficient. All right, and like we talked about, when we have numbers next to each other like this, what do we do with them?
Have to do that thing. The multiplication.
We just multiply, right?
Yeah.
So now if we're representing it with tiles again, how many x's?
20.
Just how many x's do we have?
2.
2 x's, right? It says 2x. And they're positive, so they're open. And then we have plus 1, so we're just going to do 1 square. 1 open square. Now on the second one, now how many x's do I have?
Negative
3. We have 3 x's. And it's a negative 3, so they're going to be filled in. So shade in all those. And how many squares am I going to have, Caleb?
2.
And are they shaded or open? Because they're positive, right? So that's negative 3x plus 5 there.
Yep. Wow. It's equal to 2. Right?
Not quite, because we'd have to multiply here. All right?
So it'd be 15.
Depending on what x would be, we'd have to solve for x.
I don't know what X would be there. Because X isn't short.
All right, we'll get there. We'll get to that. Go ahead.
Ooh, gosh, that's good.
All right. Implied coefficients are coefficients that seem to be invisible. Is our word there? And they're 1 and -1, which we just write as x and -x. So if we have a 1 in front, if a 1 would be our coefficient, we don't have to write that. We could just write x. Or if we had -1, we could just write -x. All right? You all okay with that?
Yeah.
So instead of writing 1x plus 5, we can just write x plus 5. All right, now we just got some examples, and it wants to either give us, it's going to give us the squares, and we give the expression, or the other way around. So what would our expression look like for A here?
2x and 3.
Plus 3.
Plus 3.
2x plus 3, right? And they're both positive because we got open rectangles, open squares. What would the squares or the tiles look like?
Nate filled in. And then
Filled in what?
filled in the rectangle. And then 4 open squares.
Careful,
Or negative squares.
right? Because we're
Filled in squares.
So we're going to add 4 closed squares because we're subtracting 4. Now here's another example too of these implied coefficients, right? This is -x. We could have -1x there, but we don't need it. So we just write -x. All right, Asia, what's our expression going to look like for C?
Negative
Okay, how many x's do we have here? 3. So -3x there.
Plus
1. Good. D, why don't you guys try and come up with some tiles? I think it's looking for both. Just the expression. So why don't you guys try and come up with an expression for D on your own? All right, it says Marcus earns double his regular pay plus a $20 bonus. Write an expression that represents his holiday pay. So we have double and plus are your key words there. So
How much do we get paid regularly?
So your regular pay, how would we represent that? X.
X.
That's the one.
All right, so try and come up with an expression for that one. We're looking for the expression, not the squares, guys. If you can do the squares, it helps, but we're looking for the expression. Has everybody got something?
Yeah. No.
Manny, you got something? All right, what do you got?
I got X plus 20.
All right, that's close. What are we missing?
2x plus
2
1.
x is what we're missing there, right?
I got 2x times.
It would be, all right, let's talk about it. So we said our regular pay is just X, right? That's what we get. Every hour we work, we get X amount of dollars. But now we're earning double. So we got to take that times 2. So 2x is where we get the double from. And then it says his regular pay plus a bonus of $20. So it gives it to you right in the wording there. So that is the bonus. We add it because we're not getting $20 every hour. We're just getting $20 one time. So 2x plus 20 is what we should get there. All right. So the homework, 2 pages. First one, it just wants you to write the expression that you get with the squares. All right, filled in is negative, remember, open is positive. 2 is the same kind of thing. It just wants you to match the expression to the squares, the tiles. 3 wants you to write an expression again. So this first one we just talked about, 2 times a number. How do we represent that? How would you write 2 times a number?
What?
For number 1 on activity 3 here, we're writing expressions. How would you write 2 times a number?
Like 2 times 4?
Nope. If we don't know what this number is, how would we write it?
Negative. Or you just leave it.
A variable. Right, so we can just say 2x would be 2 times the number, right? Because we don't know what this number is. It just says a number. And then it says circle the coefficient in the expression. Don't forget that part.
What's the coefficient?
Look in your notes. We just talked about it. So what would the coefficient be here?
2.
2. So we just circle 2. All right, coefficient is the number in front of the variable. So write the expression and circle the coefficient there. On the bottom here, we have 1 through 12. We're just going to do 1 through 6.
1 through 6?
Yep.
Yeah.
So 7 through 12, cross them out. I'm not going to do them.
What are we not doing?
So-
Activity
We're going to do activity 4, just 1 through 6, though. We're not doing 7 through 12. So cross those out. All right, and then the back page is more just writing expressions. So we're going to write the expression. There's going to be 3 things for each one. Write the expression,
What is wrong with that?
circle the coefficient, and draw the tiles. All right?
No wonder he made his 2 cross out. Got it.
It says draw the...
Just cross out activity 4 then.
Nope. It only wants you to draw the tiles if it'll help you solve the problem. So if you're struggling with your expression, draw tiles. You don't have to, but it'd be a good idea.
We have to show work at least on this.
All right? On 1 through 6, you should show work, though. These ones, you have to show work. All right? Got a lot of time to